Okay, this is the second video for section 9.5. One thing I wanted to say up here is just a reminder that this is, we're looking at power series, which means you will have an n, like we had in the problems we just did, and you'll have x's. So it's important when you do these that you remember you're taking the limit as n approaches infinity. And x you can treat just like a constant because it'll be a certain value of x. So you could even put that in there, that this is going to become in the limit or behave like a constant. When I do these problems, I don't do all this u to the n plus 1. I just still do my a to the n and a to the n plus 1. So I don't know. It's up to you whether you want to think of them as u's or a's. I just like to do them like we did the other ones. So this one, the first part of the problem, I am assuming you have, so I'm going to go right to the limit as n approaches infinity. Remember, we'll have n and x's in these. And I will have n plus 1 factorial times x to the n plus 1. So that's my a to the n plus 1 divided by n factorial over x to the n. Okay, now let's do some rewriting here. I'm going to go over here where I have a little more room. So limit as n approaches infinity. So n plus 1 factorial here I'm going to write as n plus 1 times n minus 1 dot dot dot. X to the n plus 1 I'm going to write as x to the n times x to the 1. All over n factorial I'm going to write as n times n minus 1 dot dot dot. You get the idea. And then what else do I have on the bottom? Just x to the n. Okay, now let's see what one's out. X to the n divided by x to the n is 1. N minus 1, gone, n, gone. So I'm left with the limit as n approaches infinity of n plus 1 times x. And remember, you need an absolute value. I usually kind of add it at the end. Now treat your x like a constant. Okay, so if n is approaching infinity, getting bigger and bigger and bigger, infinity times a constant is still going to be infinity. So this converges at the center only. So the radius of convergence is 0. So there is no radius of convergence. This is on those number line problems. It just converges at that point. There's no values. There's no radius of convergence around it. So this is with those simplifying steps added back in. Let's look at 5. So I'm again going to start with the limit. I'm going to start it over here. Limit as n approaches infinity. N plus 1 would, a to the n plus 1 would look like this. So that's my a to the n plus 1 times the reciprocal of a to the n, which would just be 4 to the n x to the n. Okay, let's do some rewriting on this. Limit as n approaches infinity. N plus 1, just going to keep x to the n plus 1. I'm going to write as x to the n times x to the 1. 4 to the n times 4 to the 1 times 4 to the n and x to the n. Okay, what simplifies here? Well, I got a 4 to the n, a 4 to the n. What else do I have? An x to the n, an x to the n. So I think that's it. So on the top I have an x, an n plus 1, and on the bottom I have a 4 and an n. Make sure you're checking carefully so you don't forget anything there. So this is the limit as n approaches infinity of x times the quantity n plus 1 over 4n, and that should be in absolute values. So as I'm going to infinity, well, I have n over n, so all of this would approach 1 because it's the same power on there. So this limit would be the absolute value of x over 4. I just didn't put the 4 in absolute values because 4 is already positive. So this will converge when the limit is less than 1. So what I want to do is solve for x here. So, because remember, I'm finding the values of x for which the series converges. So if I multiply both sides by 4, I get absolute value of x is less than 4. How do I represent that? That's this, right? So this says x is between -4 and 4. So the radius of convergence is 4 over here and 4 over here. So therefore, the radius of convergence is 4. Right? If you picture that number line again, I have a point in the middle, and then I go 1, 2, 3, 4 this way, 1, 2, 3, 4 this way. So the radius of convergence is 4. Okay, one more. So go ahead and think, you probably already have your limit written. So I will write that. This would be x minus 1 to the 3n plus 3. So if I put n plus 1 in here, 3 times n plus 1, and I distribute, I get 3n plus 3. So that's what I have here. Same thing on the bottom. 3n plus 3 factorial times reciprocal of this, 3n factorial over x minus 1 to the 3n. Okay, let's do some rewriting on this. So limit as n approaches infinity. This I'm going to split into x minus 1 to the 3n times x minus 1 to the 3. So x minus 1 to the 3n times x minus 1 to the 3rd. On the bottom, think I'm going to minus 1 here every time. So my first term is going to be 3n plus 3, 3n plus 2, 3n plus 1, 3n, 3n minus 1, dot, dot, dot. Shoot, I'm running out of room here. Okay, wish this were in pencil so I could erase this. Let me just try to do my best here to squeeze this in. Times, this is going to be 3n, I'm going to put it over here, times, so 3n factorial is going to be 3n, 3n minus 1, dot, 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 over this, I'm just going to leave x minus 1 to the 3n. So this is from our last problem, ignore that. So this is my fraction that I'm multiplying. So the first thing I notice is on the top I have 3n, 3n minus 1. Well, there's a 3n, there's a 3n minus 1. So those one out. X minus 1 to the 3n, I have an x minus 1 to the 3n right there. So those one out. So really, this whole fraction is gone. And what I'm left with is the limit as n approaches infinity. On the top, I have x minus 1 to the 3rd. And on the bottom, I have these three terms. So this is 3n plus 3, 3n plus 2, 3n plus 1. Absolute value. All right, remember n is going to infinity, so my denominator is getting really, really big. My numerator is staying the same because x will be a single value of x. So this is a constant over infinity. That's 0. Therefore, my radius of convergence is infinity. Okay, so if you're still having issues with 9.5 or you'd like to see some more examples, send me an email and I'll go through maybe some homework problems, maybe not the ones that are assigned, but some in-between ones that aren't assigned. I did want to tell you that my work for the 9-5 homework is posted now. So you can see I show these simplification steps. So that should also help. That's all. Bye.